All right, so this is going to be a video involving solving quadratic structure equations. So I have 4 example problems here to kind of show you how this concept works. Let's start with the first one. All right, this first one says x to the 4th plus 12x squared minus 64 is equal to 0. And the thing I want you to notice here is that this right here doubles it. If you double this 2 right here, it becomes 4 over here. And that's kind of the sign that you're going to have a quadratic structure equation. So our u in this case is going to be that x squared right here. Okay, so if I rewrote this equation now, it's going to be u squared, because x squared squared is this x to the 4th. So it's going to be u squared plus 12u minus 64 is equal to 0. So now we have that quadratic structure. We are going to use quadratic formula. So I'm going to say u is equal to negative b, which in this case is 12. So it's negative 12 plus or minus the square root of b squared, which is 144, minus 4ac, which is going to be 4 times 1 times negative 64, which is going to be negative 256. So it's going to be 144 minus negative 256. And this is all under the radical here. And then we're dividing this by 2a, which a is 1. So we're just going to be dividing it by 2. Okay, we're going to do some quick simplifying here with this minus minus becomes a plus plus. And what you would end up with here is negative 12 plus or minus the square root of 400. All of this is divided by 2. Okay, well 400 is a perfect square. So this is just going to reduce to 20. So your answers are going to be negative 12 plus 20 over 2 and negative 12 minus 20 over 2. And both of these are equal to u. Okay, so if I simplify this, it's going to be 4 and negative 16 for our u. Okay. Now from here, I need to solve, instead of u, I need to solve for x. So u is equal to x squared. So technically x squared is going to be equal to 4 and negative 16. So if I do the square root of each of these, you're going to end up with plus or minus 2 and plus or minus 4i, since you're doing the square root of a negative. And that ends up being your answers for this one. Now, if you notice, the polynomial has a degree of 4 because it's x to the 4th. And if you notice our answers, there are 4 of them because there's positive 2, negative 2, positive 4i, and negative 4i. So that actually shows that we have the right number of solutions. It is important to understand that you can check these all on your calculator as well. This was discussed in a previous video. I highly advise watching that over again. I'm not going to waste the time in the video to show you how to do this again because it takes too long. But if you do have any questions about that, feel free to ask. Okay, let's go to the next one. All right, this next one, it says x minus 7 times the square root of x is equal to 8. So the first thing I'm going to do here is rewrite this. So instead of having the square root, I'm going to have the x to the 1/2 power. And this is going to be equal to 8. Now, the thing I want you to see on this 1/2 here, if you multiply it by 2, you end up getting the power over here, which is 1. Okay, so that shows that this problem is actually a quadratic structure equation. So I'm going to set x equal to that x to the 1/2, and now the equation becomes u squared minus 7u minus 8 is equal to 0. So now we can use quadratic formula to solve this. So u is going to be equal to negative b, which is negative 7, which is positive 7, plus or minus the square root of 49 minus 4 times 1 times negative 8, which is going to be negative 32. And we're doing the square root of all this. And we're dividing it by 2a, which is just going to be 2 since a is equal to 1. Okay, this becomes a plus plus, and you end up with 7 plus or minus the square root of 81 all over 2. Okay, well the square root of 81 is 9, so I'm going to simplify that like that. And we can simplify our u to be equal to 7 plus 9 over 2 and 7 minus 9 over 2, which would mean we have the answers of 8 and negative 1 for our u. But our u is actually equal to x to the 1/2. So we need to set x to the 1/2 equal to 8 and x to the 1/2 equal to -1. All right, from here to solve this, we just need to square both sides. So that's what I'm going to do, square both sides. And this ends up canceling here. So you end up with x is equal to 64. Okay, it is important to check this one since it involves radicals because we have the x to the 1/2 power. It involves a fraction for the exponent. So what we're going to do is plug 64 back in for x. 64 to the 1/2 power is 8. So this one does actually check out as one of the solutions. Let's do the same thing over here. We are going to square both sides. And we end up with x is equal to 1. But if you actually tested this out by plugging it back in for this x right here, it's going to be 1 to the 1/2 power is equal to -1. That is not true. So this would actually be an extraneous solution. Which means you don't actually count it. Okay? And if you look back at the original problem, you'll notice that the degree of this is 1. Now, it's not technically a polynomial because it's the x to the 1/2 power, but you still do have one solution there. So that's the answer to that one. Also, if you wanted, you can take this 1, this extraneous solution, and plug it into the original, and you would get 1 minus 7 times the square root of 1, which is just 1. And this is equal to -6, which is not equal to 8. So you can see right there that it's actually not, you can see right there that it's not actually a solution. Now, if you did the same thing with 64, let's do the same thing with 64. So we're gonna have 64 minus 7 times the square root of 64 is equal to 8. Now, if you actually broke this down, this would be 8. So it's gonna be 64 minus 56, which is 8. So that one actually does work, and it is our only solution for this problem. On to the next problem. You can see right here right away that this is this doubles to 4 right here, so that means this is quadratic in structure. So we're going to set our u equal to x squared again, and then we're going to end up with u squared minus 5u plus 4 is equal to 0. From here, we're going to use quadratic formula. So now it's going to be negative b, which is negative 5, which is 5, plus or minus the square root of b squared, which is 25, minus 4 times 1 times 4, which is 16. And then that's all under the square root. And we're going to divide this by 2a, which a is 1, so we're just going to be divided by 2 again. This right here becomes 9, so you have the square root of 9. So this is going to be 5 plus or minus 3 divided by 2. So this means we're going to have 5 plus 3 over 2 and 5 minus 3 over 2, which means our two solutions are going to be 4 and 1. So from here, I'm going to put the x squared back in there. We're going to do x squared is equal to 4 and x squared is equal to 1. And if you solve both of these, you're going to have x is equal to plus or minus 2 and x is equal to plus or minus 1. Okay, again, you can test these out. One thing that's kind of nice with these is it shows 4 solutions and the degree is 4, as we talked about before. So there should be 4 solutions on that one, which there are. All right, let's go to the next one. This one's a little bit harder to see, but there's a power of 1 right here, and you can see that it goes from 1 to 2 going this way, so it doubles. So this is actually quadratic structure as well, only the u is a little bit different because the u now is going to be equal to x plus 2 all over x. So if I rewrote this equation, it's going to be u squared minus 2u minus 3 is equal to 0 because I moved the 3 to the other side. All right, let's use quadratic formula on this, and we end up with u is equal to negative 2, which is 2, plus or minus the square root of negative 2 squared, which is 4, minus 4ac, so it'd be 4 times 1 times negative 3, which is going to be negative 12. And then this is all going to be divided by 2. We got a plus here. You end up with the square root of 16 in there, which is 4. So your answer is going to be 2 plus or minus 4 all over 2, which is equal to 2 plus 4 over 2, and 2 minus 4 over 2, which these are equal to 3 and -1. So we're going to resubstitute the u in, only this time our u is x plus 2 over x, which is kind of a weird expression there, but that's okay. We're going to do x plus 2 over x is equal to 3, and x plus 2 over x is equal to -1. Okay, I'm going to multiply both sides by x, so you're going to get x plus 2 is equal to 3x. Do the same thing over here. X plus 2 is equal to -x. Okay. Subtract off the x here, and you're going to have 2x is equal to 2, so x is equal to 1. That's one of our solutions. We're going to subtract, actually let's add this x over here so we get 2x and subtract the 2 over to the other side. And then we're going to end up with x is equal to -1, and you have your two solutions. Now, the fundamental theorem of algebra doesn't actually apply for this problem because technically it's not a polynomial because we're dividing by x here. But even so, there are still two solutions for this. If you wanted, you could as well, you could check this. So if you plugged in 1 to the original equation for x, you should get 3 out of it. So those are 4 example problems involving quadratic structure equations. If you have any questions about anything in this video, let me know.